Hello everyone, good day. We are Group 3 and this is the continuation of our report about complex system and critical infrastructure interdependence. By the way, I am Stephen Bidelfin, a member of Group 3, and last meeting we are done uh, discussing about what is complexity, what is complex system and its example, and also we are done in discussing about uh, complex adaptive system, protection function, and also the advanced interfaces for mobile information supports. So now uh, let's continue our report in tackling surveillance system, automatic generation of digital 3D models, uh, also the infrastructure interdependencies and what are the types of interdependency, and also um, the advanced architecture for protection of complex critical infrastructure. So we are asking an apology because last meeting we are not able to finish um, our report. So but anyway, let's continue our discussion, and I hope namoy ma-learn sa amo ang topic. So let's continue.
Hello, good morning. I will continue my topic. My topic is video surveillance. Surveillance system is consist of three main elements. First, data acquisition. Second, information analysis. And third, on-field operation. So, large surveillance system is acquire data from the hundreds of network cameras, which an increasing number of cameras and other data sensors. Information analysis becomes increasingly difficult. Human operators can easily get overwhelmed by a flood and unorganized visual information, and they may fail to effectively inform on the on-field operation and operation in as an effective way. So means the video surveillance is use of conventional user interfaces and fixed video display metrics is no longer sufficient due to increasingly large scale and a complexity of the information flow. Video surveillance system is performed very well in a relatively vacant environment. In a underpopulated scenario, people and bicycle and other objects can easily track with a robust treatment of occlusion and of a complex scene dynamics. However, as the monitored environment gets crowded, which is usually the case in transport infrastructure. So when we say video surveillance, what is a video surveillance? Video surveillance systems are not limited in just monitoring activities, but they can impact many aspects of entire security infrastructure and beyond. Videos can use to monitor activities, but they also have the power to impact the entire security infrastructure and beyond. So, ang video surveillance can nag-compose po ni siya isa ka system like cameras, monitor, and display units and recorders. Cameras may be either analog or digital with a host of possible design feature which will be discussed momentarily. Video surveillance encoder will form a resilient inter-network framework, fully and automatically redundant with itself, remotely manage and control. The video information originating from many sources will be distributed over the network to OCC stands for Operation Control Center station equipped with video display or desktop monitors and simultaneously archive for offline analysis. is automatic generation of digital 3D models. Our geometric modeling and reasoning is based on BSP, stands for binary space partition, generated cellular decomposition of buildings from architectural plans. The paradigmatic reference is to PLM, stands for Product Life Cycle Management, where the geometric information provides the exchange and collaboration layer shared by all business departments and all products data. AVR representation of whatever infrastructural part may be of interest, progressively generating higher levels of detail and may be produced at runtime by a streaming data flow process. The semantics is assigned to small subset of lines via pattern base and recognition of the components of the building fabric, internal partition and external enclosure, vertical communication elements, and etc. And a subsequent translation into PLASM scripts, symbolic generating forms. The evolution of a symbolic scripts produce the either streaming solid models and variable levels of the detail or adjacency graphs of the critical infrastructure as a whole or part of therefore. So, how to achieve this 3D modeling? So, to achieve our purpose, we capitalize on a novel parallel technology for high performance, solid and a geometric modeling that complies the generating expression of the model into a data flow network and concurrent threads and splits the model into fragments to be distributed among the different computation nodes and independently generated, are used for adaptive and parallelizable streaming data flow evaluation of geometric expression. There are associated to the polyhedral cells of HPC, stands for hierarchical polyhedral complex, or that means is data structure used by the language haze graphs are used to maintain a complete representation of the topology.
Good morning, everyone. My name is Clyde Errol A. De La Torre, and I'm tackling the infrastructure interdependencies. So, next. Interdependency. A bidirectional relationship between two infrastructure through which the state of each infrastructure influences or is correlated to the state of other. More generally, two infrastructures are interdependent when each is dependent on the other. The term interdependencies is conceptually simple. It means the connection among agents in different infrastructures in a general system or systems. In practice, however, interdependencies among infrastructures dramatically increase the overall complexity of the system of system. So, interdependency kay ang nagadepende siya sa isa't isa, like dapat system to system siya ba. Like for example, sa machine, ang sulod sa machine kay naay mga system. Kung dili mo gana ang isa ka system or guba ang isa ka system, maapektuhan jud ang tibok system or ang mismong machine kay dependent man jud sila sa isa't isa. So, next. Dimensions of infrastructures interdependencies. These dimensions and their components are descriptive and are intended to facilitate the identification, understanding, analysis of interdependencies. They do not represent comprehensive set orthogonal interdependency metrics, although they provide for a foundation for developing such metrics. So, as you can see in the picture, these are the types or examples sa parts of the report. Okay, mauna siya ang summarization sa akong report. So, these are the things na atong itackle para mas masabtan ninyo akong topic. So, kaning sa picture, pag magtugot ang infrastructure, nandiyan siya mga elements like kaning type of failure, infrastructure characteristics, state of operation, types of interdependencies, environment, coupling and response behavior. So kung magkuan mo magtukod mo infrastructure, maagian dyan niya na kan mga elements. So next, so there are 4 types of interdependencies. First, physical interdependencies. Second, cyber interdependencies. Third, geographic interdependency. And last, logical interdependency. So ato na siyang explain one by one. So first, mauna ta sa physical interdependency. So ang meaning is, a physical interdependency arises from a physical linkage between the inputs and outputs of two agents. A commodity produced or modified by one infrastructure and an output is required by another infrastructure for it to operate an input. So na ako'y nabasa sa sa module, and then ako lang siyang explain para mas madali siya. So mo yung example, for example kay railroad network, coal-fired generator plant. Ang railroad ang naga-deliver sa mga supply para sa generator, like coal as a fuel sa generator. Tapos ang generator ang naga-supply og electricity para modagan ng railroad. Kung lack of supply ang railroad para sa electrical generator, kay maapektuhan ang both railroad and generator. Kay kung ba ang generator tapos dili ma-provide sa railroad ang replacement part sa generator, this can cause halt sa delivery sa railroad, kay wala may naga-generate og electricity, and if this happens, mapugos ang railroad na mangitag alternative fuel. So mara siya ang physical interdependency. So next, cyber interdependency. An infrastructure has a cyber interdependency if its state depends on information transmitted through the information infrastructure. Cyber interdependencies are relatively new and a result of pervasive computerization and automation of infrastructures over the last several decades. To a large degree, the reliable operation of modern infrastructures depends on a computerized control system. So, kining cyber interdependency, nagagamit siya og computerized system para makatransmit og informations. So, the output of the information infrastructures are inputs to the from other infrastructure. And the commodity, the infrastructures is information. So, muna siyang cyber interdependency. Next, geographic interdependency. Meaning is infrastructures are geographically interdependent if a local environment even can create state changes in all of them. So next, a geographic interdependencies occur when elements of multiple infrastructures are in close spatial proximity. Given these proximities, events such as an explosion or fire could create correlated disturbances or changes in these geographically interdependent infrastructures. Such as correlated changes are not due to the physical or cyber connection between infrastructures. Rather, they arise from the influence the events exerts on all the infrastructures simultaneously. So, ang geographic interdependency, if ever magpabuhat kag infrastructure, dapat kabalo ka sa mga events na pwede mahitabo, like kabalo ka kung kabalo ka kung prone ba siya sa landslide or delikado ba siya sa mga kung mag-earthquake. So, mara siyang geographic interdependency. So, lastly, logical interdependency. So, logical interdependency, two infrastructures are logically interdependent if the state of each depends on the state of the other via a mechanism that is not physical, cyber, or geographic connection. Logical interdependency may be more closely linked to a control schema that links an agent in one infrastructure to an agent in another infrastructure without any direct physical, cyber, or geographic connection. So, ang logical interdependency, obviously, as you can see, is that not depend on any physical, cyber, or geographic connection. Human decision may play the predominant role in logical interdependency. In particular, example is mag-increase ang tao mag-increase ang tao na magbakasyon pagbaba ang price sa gas, which can cause traffic congestions. In this case, the logical interdependency between the petroleum and transportation infrastructures is due to human decisions and action and is not a result of a physical process. So, maulan to, and thank you.
Geometric reasoning engine, providing a multi-scale digital model of the infrastructure to be protected and supporting video surveillance and sensor fusion. Geometric reasoning engine mao na siyang product na high quality and cost-effective manufacturing, and is the key when it comes to competing successfully in this worldwide marketplace. Geometric reasoning is naga-implement of computerized enforcement para sa development process sa product, and ginaalaw sa diriya ang mag-uncover og mga design flaws. Since sensor fusion is naga-workshop para mag-fuse o mag-gather og data from multiple sensors para makaproduce og mas reliable nga information. Distributed data mining environment. Distributed data mining is a field which deals with analyzing distributed data and proposes algorithmic solutions to perform different data analysis and mining operations in distributed manner by considering the resource constraints dedicated to event discovery and tracking. Data mining is muna siyang process of sorting large datasets para makadiscover og valuable information and magamit siya for analysis para ma-increase ang efficiency sa business operations. Data mining uses software, algorithms, and other statistical methods para maka-identify og patterns na makatabang og resolve sa mga business issues. Kani siya kay mostly used in marketing, risk management, cybersecurity, and other fields. Most company kay naga-engage o naga-employ ani because essential kayo siya sa paghandle og business difficulties. Advanced Control Center, supporting situation evaluation through dynamical modeling and simulation. Control system is a set of mechanical or electronic devices that regulates other system. Control systems kay gina-identify siya as a central part sa industry kay naga-regulate siya processes including ang pag-control o pag-supervise sa industrial system. It is also important when it comes to handle all emergencies such as terror attack, massive strike, storm kay mag-result man jud siya casualties. So para ma-handle ni nga mga sitwasyon nga og mga emergencies, kinahanglan ang control center because naa siya best technologies and infrastructures nga able siya maka-adapt dayon sa mga emergency operation. Control systems are used to enhance production, efficiency, and safety in many areas including agriculture, chemical plants, quality control, nuclear power plants, environmental control, metal and mines, pharmaceutical, manufacturing, and many more. These components are best candidates to serve as a point of reference for the integration of vision, sensor, tracking, and security systems committed to infrastructure protection, provide a reliable basis for high-level situation awareness, and enable coordinated and optimized decision-making. So, ang goal ani niya tanan is para makatabang jud sa mga business and other industries and protection jud sa infrastructure. Naghatag pud siya og dugang awareness and nagapa-enhance when it comes to decision making. Complex critical infrastructure, in particular those crossing national borders such as tunnels, bridges, and etc., or affecting the everyday life of thousands of people such as railway hubs, airports, power plants, and etc., require a novel security approach and architecture. Their security, in other words, the capacity of preventing threats and reacting to menaces, should be based on a strong control and awareness of daily operations, since a security threat can arise not only from malicious attacks but also from natural events or unexpected facts like traffic congestion or collisions. Critical infrastructure includes the vast network of highways connecting bridges and tunnels, railways, utilities, and buildings necessary to maintain normalcy in daily life. It is the need to protect a region's vital infrastructure and has a responsibility to protect this essential critical infrastructure against natural disasters, terrorist activities, and now cyber threats. So kanina mga infrastructure kay everyday man jud siya nga magamit sa mga tao. Nagkinahanglan jud siya high standard nga security approach and architecture para ma-ensure ang safety and security sa katawhan. Kay ang mga system security threats dili lang man gikan sa mga malicious attacks kundi pati pud sa mga equipment failure, human error, or natural causes. And para makaprotect against sa nagkataas nga kaso sa mga threats, it is more important jud than anything else nga ilang itop priority ani nga critical infrastructure sectors and government department and agencies ang ilang responsibility para mag-formulate og mga plano for disaster preparedness, response, and recovery para ma-prepare sila to respond serious incidents nga involve ang critical infrastructure environments.